Okay, we're going to do common logs, which is 6.7, and then there will be a separate video for 6.8, which is natural logs, very similar. A common log is going to be is going to be is going to always have the base 10. Okay, so far we've had a lot of different bases down here. So whenever you see a log written with nothing in it, it has to have a 10. Okay, a log without a base is log 10, and that's the one that you see on the front of your calculator. So if you look at your calculator on the left hand side, right next to the number 7, it just says log, and when you type log 7, you get in your calculator, you get 0.8451. That's going to be the log of base 10. So exponentially, it means 10 raised to the 0.8451 is equal to 7. So you're finding 10 to what power is equal to 7. So if I was going to do something like the log of 100, we all know that 10 squared is equal to 100. So the log on the front of the calculator is going to be the log with a base of 10. Again, when we talk about log of 0.5, 10 to what power is 0.5? So you type log 0.5 into your calculator, and you might seem like, well, that's awkward, negative 0.301. What does it mean exponentially? 10 raised to the power of negative 0.301 equals 0.5. Well, type 10 raised to the negative 0.301 into your calculator, and you get something that's pretty darn close to 0.5. So when you're talking about a log that does not have a base written in it, we're talking about the common log, which is base 10, which is on the front of your calculator. Common logs are used whenever you hear how an earthquake registered on the Richter scale. The number that is associated with it has to do with the power of, it's the exponent on the number 10. So if you look at down here, if we had a magnitude of 6.4, what that means is it's log base 10 of x. The power of this earthquake would be 10 to the 6.4. So that means that you can compare things. So if we compared one that's going to wreck the state of California, if it measured 8 on the Richter scale, then the intensity or the power of it is 10 to the 8th. Whereas if you had one in the Midwest, in Kansas or something like that, and it measures 3, you can actually make a comparison. And you can say, well, what is the comparison between those two? It's 10 to the 8th divided by 10 to the 3rd, which means the one that's going to put California into the ocean is 10 to the 5th, or 1, 2, 3, 4. It's 100,000 times more intense. So when these numbers are actually going up exponentially, when you're talking about the difference between intensity of on a Richter scale. You can. It also has to do a lot with sound. We can do some sound things here. So it says this is the loudness, or whoa, whoa. This is the loudness or the decibels. Okay. I is the intensity of the sound. M is the minimum intensity. So you've got this over here. So if we can hear something at 66.6 decibels, that's going to be the loudness. And then I have 10 log, how many times the minimum intensity of sound detectable by the human ear, if the M is equal to 1. So then it's I divided by 1. Well, now we could solve this pretty quickly. 6.66 equals log of I. Well, how do you do this? 10 to the 6.66. That's what you type into your calculator. So you change it into exponential form. Oh, there was and 10 to the 6.66 apparently is 4,570,882, which is quite intense, I suppose. Here's the big thing that you're going to use now. We can now solve for variable exponents. Okay, so in the past we did log base 5 of 62, and of course there is a place on your calculator to do that. But more often than not, we're going to use the common log to solve things, and this is used extensively in pre-calc and extensively in calculus and in any other math class you're going to take. So the common log is going to be a big one. So what you can do is you can take the log of both sides. And that's the beauty. It's just like multiplying on both sides or adding on both sides. And now the wonderful part is this can swing out front. X log 5 equals log 62. And now you can, log 5 is just a number. It's something that your calculator will do for you. And now I can take my calculator and actually do log 62, just using that front log key, that common log key, divided by log 5. And that's the beauty of it. And it gives me 2.5643. What a wonderful number. It has so many digits in it that are next to each other. And now I can do 5 raised to the 2.5643 to check my answer. I get 61.996. Sounds like 62 to me. We are good. So we take the log of both sides. Same thing here. Take the log of both sides. That's going to be the best way to get these things done. So I get log 3 to the x equals log z. Yes, there's more than one way to do this. Swing that x out front. That's the beauty of the rules of logs. And I'm writing too fast, which means I'm losing my mind. Oh, I'm not losing my mind. Divided by log of 3. Type it into the calculator, and I get 2.579. Probably that one right about there. Yeah, that's good stuff. Take the log of both sides. Okay, if you stop paying attention, start paying attention, because this is going to be the hardest thing that you have to do. Had to take a drink of coffee and prepare myself for this. All right, here we go. You ready? Good. Take the log of both sides. Okay, so I'm going to take the log of both sides and I'm going to swing these out front. I've got variables on both sides. 7x times the log of 3. Apparently I decided to use parentheses. I'm not sure why. Oh wait, I need a 5x minus 3 times the log of 2. So all I've done is I took the log of both sides and I swung it out front. Okay. Now I've got x's on the left. 7x log 3 equals, and this is just a number. I'm going to distribute this in. 5x log 2 minus 3 log 2. Okay, now what I need to do is I need to get the x's on the same side of the equation so I can factor an x out. We are solving for x and we have 2 of them. How do you go from 2 x's to 1 x? Get them on the same side, so I subtract 5x log 2 over, and over here I have negative 3 log 2. Now I take an x out, and when I take an x out, I'm left with this. And now I could divide both sides by this. I would clean this up first. I would put the 3 up, the 7 up there, and I'd put the 5 up there. And I would turn this into a single log of 3 to the 7th divided by 2 to the 5th. A lot happened right there. I understand that. And you could put this up there too if you wanted to, but I'm just going to leave it. Okay, so 3 to the 7th, 2 to the 5th, minus sign means divide. Now I can divide by this, and I'm just going to let my calculator do the work on those. 3 to the 7th over 2 to the 5th. It's like when I write on the bottom, it gets worse. So in my calculator, I am typing negative 3 log 2 divided by log 2 to the 7th. Divide, whoa, that's a 3. See, my writing on there is terrible. 3 to the 7th divided by 2 to the 5th, and then close my parenthesis. So I put that, this is a 3 right here. Yeah. I put that into the calculator, and I get negative 0.4922. You can check your work by plugging the negative 0.4922. Geez, I can't even read that. Negative 0.4922. That's a 9. Holy cow. 3 raised to the 7 times negative 0.4922 gets an answer. Then do 2 raised to the 5 times negative 0.4922 parenthesis minus 3 gives you an answer. I got for both of them 0.02270, and then it goes off on rounding error, but I get the same thing. Okay, so the key to these things is right here, people. You need to get the x terms together on the same side so you can factor it out. That's how you solve for a single x. Take the log of both sides, collect the x's on the same side, and then simplify. I use some log rules to simplify right there. Okay, change of base formula. You can change any base into log base 10. That's this is a big one because you don't always have a calculator that does something in log base. There is a log base spot in your calculator to do that, but notice the base goes booyah and goes to the bottom, and the other number comes up top. So if you type that into the calculator, you will get the same thing, which you can change anything. You can change it to any base, but more often than not, we're going to change things to base 10. Okay. There's a proof there. Great. Okay, so log base 5 of 140. You can use the change of base formula, and we go log 140 divided by log 5. The base goes booyah, goes to the bottom. Okay, that will always be the case. Type that into your calculator, log 140 divided by log 5. And I get 3.07. 3.07. What does it mean? 5 to the 3.07 is 140, which shouldn't surprise us. 5 cubed, 125, a little bit more, 140. Good stuff. This would be log 16 over log 5. Change of base formula. The base goes booyah, the base goes to the bottom. The base goes down, the 16 goes up, they each get a log. Now we're in base 10, we can use the nice deal there. Okay, there's some homework probs for you, and we're going to push on with 6-8. So you're going to want to do the 6-8 homework next, or 6-8 video next.